Welcome back to the deep dive. Today we're tackling something pretty mind-bending: knowledge distillation in AI. Teaching a smaller AI model all the smarts of a giant one, but without needing a massive supercomputer to run it.
Precisely. This paper we're looking at, Learning with Less, Knowledge Distillation from Large Language Models via Unlabeled Data, proposes a revolutionary approach.
And the really cool part, they're doing it with unlabeled data. I mean, think about the possibilities where we can unlock all that information that's currently just sitting there, unused.
It is a game changer. Right now, these massive language models like Llama and GPT-4 are incredibly powerful, but they're also incredibly resource intensive.
So using them for everyday applications is kind of like trying to run a marathon with a refrigerator strapped to your back.
A very apt analogy. That's why making smaller, more efficient models is crucial. We want to bring the power of AI to everyone, not just those with access to supercomputers.
All right, so smaller models, less resource intensive. Makes sense. But how do we make sure they're still as smart as their giant counterparts?
That's where knowledge distillation comes into play. It's like a mentor guiding a student, sharing their expertise without overwhelming them with every single detail.
So the smaller model learns from the best, but in a more streamlined way.
Exactly. The traditional approach to knowledge distillation relies heavily on labeled data, which can be expensive and time-consuming to obtain.
But this research found a way to bypass that, right?
Yes, they've figured out how to use unlabeled data effectively. It's a bit like learning by observing an expert at work, picking up their techniques and insights through their actions rather than explicit instructions.
That's fascinating, but how do you teach a model using data it can't even understand?
Well, they used a large language model to create pseudo-labels for the unlabeled data. Essentially, the large model acts like a translator, making predictions about the meaning of the unlabeled data based on its vast knowledge.
So it's like giving the smaller model a rough draft, a starting point to work with.
Precisely. But of course, there's a challenge. These pseudo-labels aren't always accurate. They can be a bit noisy, which could lead the smaller model astray.
Right, because even the most brilliant expert makes mistakes sometimes.
Absolutely. To overcome this hurdle, the researchers cleverly combined two factors: teacher confidence and student uncertainty.
Now, those sound like they could be pretty critical.
They are. Teacher confidence reflects how certain the large model is about its pseudo-labels. Higher confidence means the data point is more likely to be accurate.
Okay, that makes sense. And what about student uncertainty?
That indicates how confused the smaller model is about a particular data point. High uncertainty signals areas where the smaller model needs more guidance.
So it's like the student raising their hand and saying, wait, I'm not sure about this part, and the teacher knowing whether to offer more explanation or let the student figure it out.
Exactly. This combination helps ensure that the smaller model learns efficiently from the most reliable data points, without being bogged down by inaccuracies.
This is already blowing my mind, and we're just getting started. Now, the big question is, does it actually work? Can a smaller model really perform as well as a large one with significantly less data?
The results are truly remarkable. They tested their method, which they call LLKD, on 5 diverse datasets ranging from medicine to social media to scientific papers. And what they found, well, let's just say it's pretty exciting. LLKD consistently outperformed other knowledge distillation methods across the board. What's really remarkable is the level of data efficiency they achieved.
Okay, give me the numbers. How much less data are we talking about here?
In one instance, they used a mere 3.7% of the original training data and still saw a significant performance boost. It's a testament to how effectively this method distills knowledge.
So it's like finding the cheat codes for AI training, but in the best way possible.
I like that analogy. It really highlights the potential of this research. We're not just talking about incremental improvements. This could fundamentally change how we develop and deploy AI.
What are some of the real-world implications that you find most exciting?
Well, imagine being able to run sophisticated AI models on devices like your phone, or even in remote areas with limited internet access. This technology could democratize access to powerful AI tools, bringing them to people and places that previously couldn't even dream of using them.
That's a powerful thought. It could revolutionize fields like healthcare, education, even scientific research.
Absolutely. Think about personalized learning experiences tailored to each student's needs. Or AI-powered diagnostic tools that can help doctors in underserved communities provide better care. The possibilities are truly vast.
And it all stems from this idea of learning with less, which seems almost counterintuitive in the age of big data.
It is a paradigm shift. Instead of simply throwing more data at a problem, we're becoming more strategic, focusing on the quality and relevance of the information we use to train AI models.
It's like we're moving from a brute force approach to something more elegant and refined.
Exactly. And it raises some fascinating questions about the future of data itself. What if we can unlock the potential of all that unlabeled data that currently sits unused?
It's like we've been staring at a vast, untapped resource all along, not knowing how to access it.
Now we're starting to develop the tools and techniques to make sense of it all, to extract valuable insights and knowledge from this sea of information.
This research seems like a major step in that direction. It's not just about making AI more efficient. It's about making it more intelligent, more insightful.
And ultimately, more beneficial to humanity. I truly believe this has the potential to not just revolutionize the field of AI, but to have a profound impact on society as a whole.
That's an incredibly inspiring thought. I'm curious, what are some of the challenges or potential downsides that we should be thinking about as this technology develops?
That's an excellent question. One thing to consider is the potential for bias in the pseudo-labels generated by the large language models.
That's a really important point. We've seen how biases can creep into AI systems, and this method could potentially amplify those biases if we're not careful.
Exactly. If the large language model used to generate the pseudo-labels has inherent biases, those biases will inevitably be passed on to the smaller model. That's why it's crucial to address bias in these large models from the outset and to develop robust methods for detecting and mitigating bias throughout the knowledge distillation process.
It sounds like there's a real need for transparency and ongoing scrutiny as this technology evolves.
Absolutely. We need to be vigilant in ensuring that these AI systems are developed and used responsibly, ethically, and in a way that benefits all of humanity.
Well said. It's a powerful reminder that even with these incredible advancements, we can't lose sight of the human element.
I completely agree. At the end of the day, AI is a tool. And like any tool, it can be used for good or for ill. It's up to us to guide its development and application in a direction that aligns with our values and aspirations.
This has been an incredible deep dive. I feel like we've only just scratched the surface of what's possible with knowledge distillation and learning with less. It's exciting, it's challenging, and it definitely makes you think about the future of AI in a whole new light.
I couldn't have said it better myself. It's a field ripe with potential, and I'm eager to see what breakthroughs and innovations emerge in the years to come.
And for our listeners, as you go about your day, here's a thought to ponder. If AI can learn so much with less, what does that mean for us as human learners? Could we be more efficient, more focused, more discerning in how we acquire and process information? Something to consider as we navigate this ever-evolving world of knowledge and technology. Thanks for joining us on the Deep Dive.